This video will cover the work-energy theorem. As we know, work is equal to force multiplied by the change in x. When we expand this equation, we get mass times acceleration times the change in x is equal to work. When we continue to expand this equation out, we get this large equation at the bottom. And this large equation at the bottom is equal to work. When we simplify this equation, we will get the work-energy theorem, which states that 1/2 mass times velocity squared is equal to 1/2 mass times initial velocity squared. So, this means that the work total is equal to the change in kinetic energy because of the first portion of this equation, 1/2 mass times velocity squared is equal to kinetic energy. And kinetic energy is the energy an object possesses due to its an object's motion. So let's try an example. A 300-kilogram car is moving at a constant speed of 20 meters per second. The car then accelerates to 30 meters per second. Find the work total. So, the first thing we're going to do is write out the work-energy theorem. And then we're going to plug in our variables. So we know the mass of the car is 300 kilograms. We know the velocity of the car is 30 meters per second. And we know the initial velocity of the car was 20 meters per second. So, when we plug in our variables, we will get this equation. And when we solve this equation for work, we get that the work total is equal to 75,000 joules. Let's try another equation. A 1,000-kilogram car is being pulled 10 meters out of a ditch. It has a tension force of 250 newtons and a velocity of 2 meters per second. If the velocity initial is 0, what is the kinetic force? So the first thing we're going to do is draw a free body diagram. And we're going to label all our forces. And then we're going to write out the work-energy theorem. And by doing this, we're going to plug in our variables. So we know the mass of the object is 1,000 kilograms. We know the velocity of the object is 2 meters per second. And we know the initial velocity of the object was 0 meters per second. So when we plug in our variables into the equation, we get this. And because the initial velocity is 0, the second portion of this equation cancels out. So, we will eventually get work is equal to 2,000 joules. And by doing this, we will create another equation. So, the tension minus the kinetic friction multiplied by the change in x is equal to work. So we're going to plug in our variables. We know the tension force is equal to 250 newtons. We know the change in x is 10 meters. And we know work is equal to 2,000 joules. So when we plug in our variables, we get this equation, and when we solve this equation, we will get the kinetic friction is equal to 50 newtons. So by solving this equation, we got the kinetic friction of the car.